Hi, hello, good afternoon, everyone. Hope you hear me okay. Then first I would like to start thanking Madhu and all the Ceylon Energy team for organizing this great event. That's great that this gives us the opportunity to basically share experiences, right? I have here a ton of slides and information. So I expect that then after all this presentation, we'll have the opportunity to share this kind of information, what you like to hear, what you want to know, and how we move further from here. So let me start just having, again, the Mr. Hubble picture. You will know him at the end of this presentation. But there's another guy there who is Mr. Edison there behind him. And why I have these two guys here on the slide? So mainly because there is a relation between them, but also because it's a personal, not a personal relation, because they are not anymore there, but yes, a professional relation for me. And why is that, right? I am part of Hubble now, but I started my career on General Electric more than 30 years ago, a long time ago. I was working for General Electric in the electric business with different roles, different products. So I started with protection and controls, then I moved to substation automation, then I moved to communications, then I ended up on the General Electric metering business. I was part of that General Electric metering business. And what happened in 2015 and then finalized in 2018 was that Hubble acquired the General Electric business from General Electric. So that move, all that experience of more than 100 years of building meters that was transferred from General Electric to Hubble. So now it's part of Hubble. So on those 30 years, I have had the opportunity to see how the network has been transformed, right? It was from the one direction power network. So at that time, it looks complicated, right? But you had generation, you had transmission, you have distribution, and you have the consumer. Now looks easy, right? We would say, hey, that should be easy to manage, because now we have additional complexity. Now we have renewables, then you have customers asking for different tariffs, you have connections in between here and there, we have the power not flowing in one direction, but flowing in many directions. So we have additional complexities in the network that is creating these new challenges, right? Which that's why I like as well the word Energize, because this is not a boring business. I mean, we have the network is transforming, communications are transforming, we need new solutions to new problems. It's not the same problem that we need to solve. We are having new challenges that we need to face. And what is happening now is that the communications, and especially we'll talk about the edge very often in this presentation, is becoming more and more critical. So the network can be managed only if we know and we have enough information. It's not anymore valid the old days where I started in the protection and control relay business. We were reactive. We are building better and better protections for the transmission and distribution lines to react faster, to try to minimize the impact. So if I have a fault in a line, I block that line, but it's not transferring to the other one. If I have a fault in the bus bar, I just isolate that quickly. But it was always reactive. We were not waiting, but we were reacting when the fault was there and the line was disconnected. Now it's not anymore like that. What we are doing now is trying to create proactive network and proactive solutions where by having information and visibility on what is happening in the network, we can react quickly. So now this part of, in this new environment, the communications are key. And the metering capabilities that we are building now in the new metering and AMI solution is giving us very good tools to do so. So let's start by defining which are the trends and challenges. And I like very much this slide because this is a slide that is being presented in US, and I have not changed a comma in this one. And you will see how this applies to here in Sri Lanka, but this applies if I go to many countries and do this presentation, and I put this slide, we say, hey, yes, that's what is happening here, right? In the grid modernization, the infrastructure is aging. There is still many part of the network that have not been modernized, that are still being dragging on for many, many years, and they have to be changed. The infrastructure investment, yes, we talk about electrification, so there must be investment put in there, right? And that's something, a need that we need to be identifying. The outages length, I was just coming here from the hotel and just was a TV just on with no sound, but I could read here, there has been a very national blackout in Cuba just recently. I think it was happened tonight, that they are not able to recover. We had a big blackout in Spain very recently. So that is happening more and more. And why? Because, as we said, the network is getting more and more complex. So then the challenges we have on electrification is the consumption will go up. The industry and transportation, the renewables is going to be increasing. And Sri Lanka has very aggressive targets as well for renewable integration. This already, a big of that is already done, and it's creating some challenges in the network, but more has to be done. And finally, as well, the electric vehicle is going to be creating as well new challenges here. When we have the quantity of electrical vehicles is going up, we will see that these challenges will increase. So in here as well, those topics, right? I write this here because probably all those terms that we are having here are in our conversations when we talk about network and electricity. Distribution automation, very important. We are getting more and more products that are being integrated in the network or give advantages, as we'll see in this presentation, in having them integrated in the network. Then we have the edge computing, analytics, very important. We'll be talking about AMI 2.0, which means that, okay, yes, we are having AMI and communications now where the meters are delivering information. Fine, we are using it, we read it, we can bill there quickly, but we have a lot of information, and there are many things we can do with that information. And during this presentation, I have to go quickly because we don't have much time, but I will be showing some examples of what can be done with that information, what is being now think about automating things or having face identification, or what kind of functionality can be added there. In the center of it, I put cybersecurity. Very important, key in this one. We are accessing and giving communications to many critical infrastructures. We are communicating substations, we are communicating meters, we are communicating a lot of devices that are in the network. So it's very important that the cybersecurity is considered very much. So that's something that from Hubble we give a primary importance. All our devices have the top side of cybersecurity, the internal processes, the products, everything is related with that. So when we talk I talked already about the edge a bit, but I would like to come again with that concept, right? Because I think that's part of the evolution and revolution that is happening now in the network. So what we consider the edge? Right now there is, okay, what I said, right? When I started 3 years ago, there was no communication. There were some SCADA communication and controlling the substations, but pretty much was binary signals being sent. Then, yes, we got, and most of the automation at the substation level has happened, so then we have pretty good SCADA system, so we know what is happening at the medium voltage level. But now there is the next step where we are in the process, and I know Sri Lanka is moving in that direction as well, of deploying smart meters, which the initial, and we'll see this later on, initial phase is, yes, I want to know what's going on, read the meters, right? I want to get the energy, have the flexibility to apply some tariffs, but we are generating a very powerful network there, what we call the edge. So adding information there, we will be able to interact with the higher level, what we call it is behind, or the lower level, which is behind the meter. So then we will have a lot of flexibility to give additional functionality and additional value to the customer with the information we got from the meter, and also to control what is in the higher position. So at Hubble, we are in a very good position in there. Why? As Fabio was explaining, we have a very broad range of products, both covering from the high-end transmission level and moving with what we call the HCS solution we have as well on the low voltage side. And we have all the know-how on the products on the edge, right? The metering, the communication, the distribution automation equipment, the sensors that we'll be checking later on. So that is pretty much showing that, right? We have a utility solution, so what we will be getting, right? Smart grid communications, they are pretty much in place as well to the medium voltage level. That's communication. The smart metering that is having as well all those communication capabilities. But we are adding as well more and more sensors in the network. So we are having more and more devices that are able to communicate. And then integrating all that is going to be a key need for the substation. Then we go with the software and analytics. Again, something that is evolving very fast, something that we are investing also heavily in saying, okay, and that's the discussion that we are having now with many customers is saying, okay, fine, I have a lot of information. I do my automated billing, I do these kind of things, but what else can I get? How can I start using that information to give added value to the customers, right? And have what we call the enhanced utility solutions. So this is a scheme just to show different products that we have or different solutions we have there, right? You see there, I highlight the three on top left on green, because those are the ones I will be talking about. I will be talking about the smart meters, I will be talking about communications, and I will be talking about line and pole sensors, which are some sensors we have, I will explain. But we have many other products. We have the grid data management platform, installation services, regulator controls, capacitor control, protective relays, recloser, automatic switchgear. So there is many other things that I will not be covering, but all are in the same environment, right? All are devices that can be smart, that can have communications, and there are devices that can be integrated in the same network, and then you can interface some with the other. So that's a simplified version of the previous slide, which basically we will have, I will explain the data communication network, and I will be focusing in two main aspects of the communication. One is cellular, and the other one is in one very special solution we have especially for non-crowded area, which is a PLC, power line carrier communication, that is very well suited, and I think it could be very successful here in Sri Lanka, which is very much to connect in places where you have dispersed population, you have remote areas where you don't have cellular communications, and where we can reach them with a very simplified solution. So I will start with the smart metering products, and I will begin with the facilities we have. We have two main facilities at Hubble that are covering smart meters. One is in US, is in North America, in Portsmouth, where basically they manage all the manufacturing, engineering, and support from the ANSI meters. And then the other one is based in Europe, where I am coming from. Is based in Bilbao, Spain. And then we have the Center of Excellence for all the IEC meters, which is all we'll call the international market piece, covering all Asia, Europe, and Africa, and Latin America. So with IEC meters, I will not go in much detail. I have a couple of slides. I will go quickly, but I would like to emphasize what I said before, right? ACLARA maybe is not a very well-recognized brand in many places as meters. Is getting more and more, because we have been quite recently, like 10 years ago, acquired by Hubble. But ACLARA is the General Electric meter brand. So I set a picture on the top left of a very old General Electric meter. In fact, the first meter that was invented by Edison, because Edison was a smart guy. So as soon as he built the line and connected electricity, he put a meter to charge for. So then he was willing to measure the electricity because he was going to charge the electricity. So he was a clever guy. He was a businessman. So the first meter that still is in our offices in Portsmouth was a chemical meter. So there was a kind of chemical process, and they start metering. And since then, we have had all the evolution of the different meters. So we have a very broad family of meters. But I will be focusing in the two that are in the right, which are the SGM, what we call the 1400 and the 1500, that are the ones that would be now more best suited for the applications here in Sri Lanka. And they have, I will explain the flexibility on the different products with different communications and so on. So functionality or characteristics of these meters, right? I will start with the 1400. I don't know if some people will be more familiar, some people will be less familiar, so I'll keep this conversation quite high level. But these are smart meters. What does it mean? Those are meters that will include communications. So then I will go through the functionalities they have and so on, but they are quite standard in the metering business, but those devices, they have the top head of the functionality. So they will have special functions that will be going very quickly, and then later on, if we have more time, we may have some specific conversation. So what we have built in those meters as well is not just a simple solution for some applications. We cover different applications that you may have in the smart metering world. So for instance, we have the single-phase meter, the 1411, the 1415, which is the 5-terminal, which is the one when you have heating, and then you need an additional terminal, so then this is a specific meter for that. One, the dual-element meter that we have there, which is a meter which in fact is like having 2 meters in one. It has 2 measuring elements. So during these days, we have had the opportunity to meet with different people from utilities, and we have been listening which are the issues you have, or the challenges we are having here, which are pretty much the same that are in other markets and in other parts of the world. So for instance, one of the discussions we were having, okay, what about houses that now are having a solar panel? And then we have this kind of net billing situation where the consumer sometimes is getting energy from the network, but sometimes they are exporting energy to the network, and sometimes you need some kind of address it by saying, okay, how much is importing, how much is exporting, how can I measure that in an efficient way without maybe using 2 meters or put in some complex situations. So these kind of meters are designed for that. They have 2 elements, so then you can have a balance, internal balance, so then you can measure how much is being imported, how much is being exported. You may have the net value, so then you have a lot of functionality around that. I will not go through this detail, but it is pretty much to show that they have all the functionality, right? Other than they have standard protocols like the elements COSEM, extended temperature range. They have all kind of functionality on the LCD where you can configure everything. And I will focus on the ones that are on the top right, which is all the information that you may have, like configurable time of use. Now, right on the meters, what the customers are asking us is, okay, maybe now I don't have yet the ability to apply different tariffs to different times of the day, different period of time, have a higher charge or lower charge during vacation period, but I want to have that flexibility. That's what we are talking about, okay, what's next, right? Right now, the focus is in reading the meter and billing properly, but next is going to be how I am going to do all these functionalities. These meters, they have all these kind of functionality already built in. Event logs and alarms, also more and more important, because you can get information from the meter, which is and that's if you have the proper management of those alarms, give you a lot of information. For instance, if you have a meter that is telling you, oh yeah, I am disconnected, or I have this issue, and then you have something, and you receive this from a group of meters of a location, you may quickly, even before anything happens, or if anyone is calling you, you can react and go there and fix the issue and say, hey, I am receiving the information, so this is happening. So I will explain this a bit more in this case because it's related with communications. So in here, these meters, what they have is on the top head, you see in the top of the meter, you see that's the meter, and then you have a module which is built in, which is attached to the meter, and that's removable. You can remove the communications and you can put a different communication module. So this gives you a lot of flexibility because you will have, for instance, the TWAX module, which is a PLC that I will explain briefly later on, or you may have other options like RF and cellular. So right now, what we see that is being deployed in many areas where it is new deployments is a combination of cellular and PLC, which works very well. Why? Because right now, having, for instance, the radio and deploy a new radio infrastructure is being quite complicated. And that happened in the past because cellular was not so evolved as it is now. Now the telco companies are are offering very good solutions in terms of cellular for smart meters, now with the new 4G bands and with this LTE Cat-M. So they are offering different opportunities or different possibilities and technologies to connect the meters. The issue is that those technologies, they don't work in all areas. You don't have cellular coverage maybe in some areas, so some areas can be difficult to reach. So then we have that combination of the PLC that I will be explaining now. I will skip this one. It's the other meter that is built-in communications, and I will go to the trucks. And that's the communication I was talking to. This is very optimized for what is called geographically dispersed, so for remote areas. And why is so interesting? Because all the communication equipment is a power line carrier, so the communication signal goes through the power line. So, and all the communication equipment is built inside the substation. It's within the boundaries of the substation. So you don't need to have additional equipment outside. You don't need to have gateways or anything as other PLC technologies, because this PLC signal is going through the distribution transformers. So you may have, this is the medium voltage transformer, you send the TWAC signal through the cable, it goes through the distribution transformer and reaches the meter. So then in here, that's something that is very attractive for distribution utilities, because the distribution utilities know how to manage a substation. They own it, and they know how to manage. They can install equipment. They can have everything well organized there and maintained properly. So then you install the communication equipment there, and it's done. Then the only thing you have to do is in the other side of the line, just install the meters in the customer houses. So in places where you don't have the ability to have cellular, this is working very well. So on top of that, then is another additional value of this is that you may say, yeah, okay, now I don't have cellular coverage in some areas, but I may have quite shortly. So what can I do? So then what you do is you have the possibility to have, and we have done this with some customer, where a customer is having a meter with a cellular communication, sorry, with a TWAS communication, and then can go and replace the module and put a new module on top of it. And then you have converting a module that was working in TWACS for several years, and then you say, now that I have cellular coverage, I can replace it and put a new module on top of it. So this is a bit the way it looks like. You have different modules in the substation. They are built inside the substation, and that's everything you need to have. You install the equipment in the substation, communications is done. Then the only thing you have to do, other than that, is install the meters in the meter's house. I see I'm running out of time. I will move very quickly. It has also some other functionalities. You may have a smart lighting as well, and connected to this same TWAC system. So then you have additional functionality like fault detection and so on with this same technology. Okay. So then I will pass the recap. I'm running out of time. So let me now discuss a bit on what we call AMI 2.0, right? And that's what I was already explaining, so that's why I'll work with cloud. The communication on the meter, on the network, it has been evolving, right? It has been gone from the initial AMR, which was only advanced metering reading, which was one way only metering reading. So then you move to next stage, which was the plus, which you were getting more information from the meter, but still was not a one-directional. The meter was not able to receive any information, so that was limited. And then we move out to MI 1.0, which is basically where the advanced systems are now, right? Which is, I have a meter that is communicating, is bidirectional, I am able to retrieve information from the meter, I am able to deliver information from the meter, I am able to read, I am able to build, I am able to disconnect the meter, reconnect the meter, so you have bidirectional. So that's, okay, and now we are moving and the conversation is going to AMI 2.0. What is that? So it's all the other functionality that is adding onto this network, right? So it's saying, the meter is not just how we call a cash register, right? It's not just getting information to retrieve information. It's more a sensor. So then you may have, as they're increasing memory, you may have algorithms inside it. So then you may have peer-to-peer communication. You may have even some artificial intelligence algorithms inside. We are developing some products with a big amount of memory, so you can start building additional functionality in those meters. So then you may have a lot of the networks supporting different applications. You may have features that are for consumer engagement. You may have all this flexibility you may have on peak pricing, time of use, have different tariffs, have different type of models that you may have depending on the usage of the energy. So here I have a list of applications. I will go only through the headlines just to show you quickly. For instance, there is one of them is face identification. And this is part of 2.0, right? You say, OK, as I know the meters, and the meters have the capability to identify the face, you can run face identification. So you can run and understand each of the loads, each of the consumers, at which phase they are attached or they are connected, which is very important because then you can balance the load, you can avoid a lot of issues in the network, right? You may have intelligent control and load shedding. You have a controller, you may have as well have a reading and a measurements of all the loads that are being connected, and you may identify and have load shedding capabilities where you can disconnect some loads depending on the consumption level you have, so you avoid that you are reaching the limit of these control loads. That's the same but more advanced. Let me just review this. And that's, for instance, one of the EV charging, right? That's one example as well of AMA 2.0. You may have, there you see on the blue line how it's approaching the red line, because it would be the maximum, and you have the daily usage, and that's not good. As you are working in this topic, you know that it's better to have a flat. So you may have an algorithm where basically what you are doing is controlling the amount of energy you are giving to each one of the chargers. So at the end of the day, the car will not, if they agree to that, then they will not care. Instead of charging the car in 2 hours, it's taking that night, it's going to take 4 or 5 hours. But then you reduce the amount of energy, and then you can keep all that track is set. That's another example of new applications that we are having in meters. Let me move. So finally, I would like to spend a few words in another device where we're talking about adding smartness to the network, right, to the grid. So this is a product that is as well, is a new sensor, which is attached to the line. Here on the bottom right, you can see how the product is connected. It's just directly hanging and connected to the conductor. This is for medium voltage, 6948 kV. And then you have that sensor, which is the cable is going through the sensor. And then you have all the different functionality that you may need in there. You can have live installation of the product, and then you have all the parameters of the line. It has you don't need to have any battery or anything. It's inductive charging, so then can stay in the line forever. And it gives you all the measurements of voltage, current, waveforms, and all this information that you may have. And why you use that? So I will go quickly through an example because I'm running out of time. For instance, you have events classification, right? This is for lines that you have. If you have a substation already monitored and then you have monitors, that's fine. But you may have some lines that are unmonitored. And here what we are showing here is that a big amount of events are not outages, right? You have 84% are line disturbances, or something that happens in the line, but it's not a fault. You don't disconnect the line, but something is happening, and you don't know why, or you don't know what, and you don't even know that is happening. So with the line sensor, you will get this kind of information of, oh, yes, something is happening on the line. Then some of them we call which is momentary. For instance, a tree that is touching a line, right? It's not a fault. The meter will not disconnect, but something is happening. This will get worse and worse and worse and worse, and at the end of the day, you will have an outage, you will have a fault. And only 4% are outages. But these 4% are, most of them, or nearly all of them, have started with something that was a kind of disturbance. So these devices, they are able to identify those disturbances early enough, they have a they recognize the pattern, and they are able to identify that there is an issue, and then you are able to go there and fix it. So that's, for instance, you have there different patterns. For instance, when a tree is touching the branch, is touching the line, you have a different pattern. If you have some arcing faults because you have a bad connection in one of the cables, one of the transformers, then you will have as well something happening, and you will have a kind of alarm, so then you can identify, you can locate where the fault is, and you can send the crew there and fix it pretty quickly. So you see that there's a lot of different functions, a lot of different functionalities that you have in this kind of network that are all integrated, are all interconnected, and they are all able to be monitored. So I have much information, but then happy to share later on over the discussions for any of the products or solutions we are having. I'm more than happy to be engaging with you. Thank you very much.